Interesting. So we have a triangle ABC inscribed in a circle O. And P is an arbitrary point on the A median. So we call this M. And then we draw the circumcircles of APB and APC. Looks like Yash had to leave. And they meet AC and AB again at E and F. So this circle, we want to see where it meets AC. Okay, so let me draw these as rays. Although I wonder if we can get it to intersect the sides, because that always looks nicest. What if this is a really tall? No, I don't think that really matters. So, oh, actually, you know what? I think we can get it to intersect. Yeah, there we go. Something like that. So let's make this a tall triangle. And all right. So this should be E. And that'll be F. And then EF meets BC at G. So that's point G. And then the circle AEF meets AP at T. And we want to show the reflection of T over PG lies on the circle. This looks interesting. All right. So maybe I should just draw like the ray PG. And okay.
Drawing the circle with center G and the radius GT.
Okay. Oh, whoops. Did the wrong circle thing. Okay. Oh, do these concur? These right here? Looks like they're right.
That is our first observation.
Is that like a McKell point? Let's see. It looks, yeah, that's like the McKell point. Of EFEC. But it's not obvious why GT equals GH. Yeah, we
looks
have,
like GT and GH are the tangents to AEF.
okay. That's interesting. All right, I'm gonna hide the circle for just a second. Okay, so basically, yeah, we want to show GT and GH are the tangents. And then maybe somehow by symmetry, if GH is tangent, yeah, let me try. We reflect T. Is H, I wonder if HT prime is perpendicular to GT. It looks true. So oh, maybe not. It's not true. My guess was not right this time. But we know, since this is the McKell point, like we know HECG is cyclic, right? Or actually, is that obvious? Or is that only true if P is on the median? Or is that like, yeah, that's not true in general, right? Like we know that these concur, but we don't know they concur on a point on the circumcircle, right?
We know that is Mikkel's point.
Does the McKell point always lie on the circumcircle of ABC too? Or is it just AEF, CEB, CEG?
It lies on 4 circles.
But those 4 circles are AEF, GEC. Oh, ABC and yeah. Oh, whoops. That's my bad. So yeah, we know that it lies on all those. Yeah. Yeah, I don't know if it's worth trying all of them. So yeah, we have a lot of cyclic quadrilaterals. So if GT and GH are tangents, then that means that this would be harmonic. This one's hard. Well, we haven't worked on it that long, but still, it looks hard. So yeah, H is a McHell point, and we want to show that GT equals GH, and that they're both tangent to the circle. So yeah, can we show GE times GF is GT squared? That would solve it. Yeah, since this is a median, yeah, I wonder if we can get like symmedians somehow. So like, let's try. So yeah, if we had a cyclic quadrilateral with BC, and we could try to get a symmedian, but So basically, I mean, we want to show HFTE is harmonic, right? That doesn't sound so bad. And we can project through A onto this circle. Yeah, okay, so that looks more reasonable. So we just want to show HBC, and this HBCI is harmonic.
No, just project to line BC.
Oh, BCM. Okay, so we want to show AH is parallel to BC. And maybe that's just an angle chase. Angle HAE. We want to show that's angle C. Yeah, so I'm going to get rid of this point I. Interesting. So yeah, we just need to show the parallelism and maybe it's better to show angle HAT as AMB. I'm not sure. Yeah, it's an interesting configuration. Yeah, I don't think that would solve the problem, but I think it would help if we prove that. Wonder, I don't think this is true, but yeah, I know that this isn't true. Yeah, that T
Oh,
is
I think I know how to prove AH is parallel to BC.
okay.
H is the center of spiral similarity, so CE over BF
Okay.
is equal to HC over HB.
Okay.
That is just similar triangles because of
Yeah.
spiral similarity. Then we basically want to show that HC over HB is equal to AB over AC.
Yeah.
Because H is on the circle, and that would mean that AH is parallel to BC. So
Okay.
I have already done that before. So intersect APC and APB with BC.
Okay.
So by power of a point, MP times MA is MI times MB, and that is MJ times MC. So basically MI is equal to MJ.
Okay.
And now we do power of a point through C to
Okay.
APB. CI times CB is CE times CA.
Oh, I see. I
Yeah.
like that. Okay, so that shows that AH is parallel to BC. That's pretty interesting.
Yeah. Also, I think maybe an angle chase would be enough for to show that GH and GT are tangents.
Oh, really?
I think, yeah.
Do you think we still need that parallel to do the angle chase, or we might not even need that?
Yeah, we need the parallel, but after we have that, I think it's an angle chase.
Okay. Because yeah, we know that the tangents at T and H concur on EF, but we don't know that they concur at point G necessarily. That's what we're trying to prove. Yeah, I was thinking about introducing these points, but then I'm like, yeah, does that really help? But yeah, it does. I like that. Angle GHE equals angle ECB, which is EAH. So how do we know GHE is ECB?
Since GCEH is cyclic.
That's a good point. Okay. So, okay. So these are all tangents. Okay, that gives us a lot of information. All right. One sec, I'll be right back. All right, so we know quite a bit now. We know AH is parallel to BC, and we know GH and GT are tangent. Okay, so we just have to finish this. So we want to show G, like if that were true, G would be the circumcenter of this. So what we could do is we could draw that circle with center at G, and we could let it intersect it at this point, and then we want to show that these are reflections over GP.
Intersect AM with ABC.
Okay.
Now PK is equal to PT is equal to PT prime.
Oh, really?
Looks like.
Okay. Interesting. So yeah, if we could show PT equals PT prime, that would prove it. And maybe P is also the midpoint of this chord. Let's see. Not sure about that. Kind of looks like it, right? Let's see. Yeah, it looks like P is also the midpoint of this chord. Maybe butterfly theorem or something? I don't know. So basically, we could draw this other point right here. And it looks like LTDK is a parallelogram. So basically, that means the power of P with respect to this circle and this circle is the same. Or negative. You could say they're negative, but so AH is the common radical axis. Maybe we could use the power ratio lemma. So if I draw the circumcircle of AHP, I wonder if HP is tangent to that circle. No, it's not. Or I was going to say GP, not HP. Basically, if we draw that circle, then we're saying Whoops, didn't mean to do that. But yeah, so we think this is a right angle. Let's see if there's any other kind of right. We drew this circle. So if P is the midpoint of this chord and PK is equal to PT prime, then that means HP and T prime should be collinear. Symmetry. Oh no, that's not true. Does that mean that P is not really the... Oh no, never mind. That would only be true if this were parallel to H. I think this is a coincidence that these are collinear. I think if I move things around, it's not true. Yeah. Basically, we want to show T prime K is parallel to LD. Yeah, I feel like there's got to be some trick to show. I really want to use the power ratio lemma, but I'm not sure exactly how. What we could do is we could take the midpoints of BF and CE. So here's a strategy. We want to show that we want to show that ANPH is cyclic, where N is the midpoint of BF.
Then we can probably use gliding principle, right?
Yeah. No, it's not gonna be that. Yeah, ANPH should be cyclic. And then, yeah, by the power ratio lemma, we would have P T equals PK. And we know MN is parallel to CF. I don't know if that helps. Yeah, I'm not sure how easy that is, showing ANPH is cyclic. Yeah, I wasn't thinking, I was saying power ratio lemma, but yeah, maybe the gliding principle also works. Yeah, maybe it's worth trying the other one. I could try to show ANPO is cyclic. Or ANOH, or I don't know. So I think ANOH might follow from similar triangles, actually.
Yeah, that is obvious.
Okay. So ANOH is cyclic. Yeah, by the power ratio lemma. But can we show that passes through P? Hmm. It's got to be like one, yeah, something we're missing here. Yeah, so this We want to show, maybe we could show VT is parallel to LK. Maybe I'll try drawing that.
PBF and PCE are similar. We can probably use that.
Okay, that seems useful.
Yeah, then it is obvious that A and PO is cyclic.
Okay.
Basically, N and O are corresponding points. And that means that POE, that angle, is PNB.
Okay. So those are similar PFB and PEC, and is that just an angle chase?
Yeah, because PEC, that angle, is equal to PBA.
Okay.
And also PFB is PCA.
So that's interesting. So did we even need that N and O? Okay, so then we know ANPO is cyclic, but we also know ANOH is cyclic. So I guess what I'm kind of wondering is, oh, because we need that P is the intersection of those circles. But like, why? Like, for example, instead of N and O being the midpoint, what if they were like a third of the way along BF and EC? Then, like for example, if
then that circle wouldn't pass through H, but it would still be passed through. It would still pass through P.
so
You can't take that midpoint R since they are similar in a different way.
oh, I think you mean the other way. It would like pass through H, but it wouldn't pass through P, right? Yeah, because okay. Yeah, I guess I wonder, yeah, like for example, let's say we have Q and R. Why wouldn't AQRP be cyclic? Because we have PBF and PCE are similar. Oh, it
But
has,
Q and R are not corresponding.
oh, because yeah, because they're not corresponding. That makes sense. Okay, because it has to be the middle. Yeah. Interesting.
It doesn't need to be necessarily, but if you took the midpoint of OC and
And
NF,
FN.
yeah.
Okay. All right. So this helps a lot. Okay. So now we know that P is the midpoint of TK by the power ratio lemma. And okay.
Now we need to show that KT prime T is 90 degrees.
Yeah. T prime. Yeah, so I could try drawing that. Let's draw that in. So yeah, let's see if there's anything special about this point. Or we could show that T prime K is parallel to LB. That would also work. So yeah, can we show that this is parallel to this? Well, if we can show that P is the midpoint of BL, I wonder if that would solve it. I'm not sure if it would. T prime K intersect BC. I could try that. That point's far away. I guess I'll move the diagram around just a tiny bit. There we go. So we have this point right here. Maybe we have like an orthocenter or something. I don't think so. Yeah, I'm not sure what to do at that point. Actually, let me check. Like maybe we have some cyclic quad. I was thinking if O is the center and we let OM meet TQ at a point, then it's getting kind of complicated. So like, O is S. Okay, so we'll just do this really quickly, although I'm not so sure how good it is. Yeah, there's nothing, I don't think that's gonna help.
But isn't HMT prime and that point cyclic?
Oh, really?
Yeah.
This point here or the point up there?
R.
Oh. I did not realize that.
You literally drew in that circle.
Okay. Interesting. I had no idea. So I just got lucky, I guess. So if we draw that and this, then they meet. That looks like it might be useful. Okay, I'm gonna erase the, okay, but we know that we could try to show that those are cyclic, HM T prime R. Are the two circles HT prime and H, are they orthogonal? Let's see. So G is the center of this one, and S is the center of that. No, I don't think this angle is more than 90 degrees. Yeah, it looks like we're pretty close. Yeah, if we could show that these are parallel, that solves the problem. So, I mean, since this is tangent, GP's tangent to the circle, we could probably get some angle like GP TH, T prime H intersects BC at S, then RS, BC are harmonic. Okay. Trying to think how we would use that. Let's see. So this is S, and you're saying those would be in harmonic conjugation. Oops. Because if you project through T prime, then we get KHBC. So is AT prime BC harmonic? Because that's what it seems like it would say. Like, I'm not sure about that. We draw this tangent and we draw this tangent.
No, but HBKC is harmonic.
HBKC is harmonic. Oh. Oh, yeah, because if HM intersects the circle at another point, then yeah, that would be a symmedian. So yeah, we can prove that RSBC is harmonic. So yeah, if this is tangent, can we use that to somehow do an angle chase to prove that this is parallel? That's kind of my idea here.
What is tangent?
Oh, what?
What is tangent?
Oh, sorry. GT is tangent, not GP. You're right. I got confused for a sec. Yeah, GP is not tangent. You guys want to finish, keep working on this problem until the end? What do you think? You want to keep working on this one till the end? Or try something different? There's one that I think is easier that we could do maybe in the next 30 minutes. But it's up to you.
I will try something different.
Okay. All right. So this last one, so this one's kind of interesting, but this last one I think is a little easier. So let's see if we can solve this and then we can try going back. So we have a circle with diameter 8b. Oops. And then we draw the tangent at D, and we see where it meets BC. Yeah, I feel like these are good problems, even though they were hard, like they weren't that complicated to state. So I feel like they're just good problems. TO cuts AB and AC at E and F. And then we want to show O is the midpoint of EF.
Looks like AEDF is a parallelogram.
AEDF, right? Hold
Yeah.
on. That's interesting. Yeah, or that would be true if the problem were true. So yeah, how do we show that? Because yeah, AO equals OD and we want to show O equals OF. And then these two triangles right here, they'd be like pseudo similar. So like these angles add up to 180. I call it pseudo similar. But these angles are the same. So basically, if we extend FC, we could get a triangle that's like similar. So I think we might be able to. Yeah. So basically, if we, yeah, there's a couple things we could do here. like basically if we draw the parallel to to OT, then we want to show that BDCG is harmonic. That's one thing we could do. Oh, sorry, I erased the tangent line. So we could, if we can show, if we draw the parallel to OT and we let it intersect at G, if we could show GBDC is harmonic, that would solve it. And then maybe we could project through D onto BC. So then we get BCT at that point. And this is a right angle. So we want to show BCT.
AEFG should be cyclic.
AEFG should be cyclic. In fact, would it be an isosceles? It would be an isosceles trapezoid, or is that true? I'm not sure. Yeah, I think it would be an isosceles trapezoid. So yeah, there's like a lot of stuff to this configuration. So I think well, okay, I don't think H lies on that circle, right? So yeah, there's a lot of equivalent things. Like we want to show GT is we want to show GD as the polar of T. That would be equivalent.
Okay, we will convert this to an orthocenter problem.
Okay.
Intersect BD and CD with AB and AC.
Okay. So D would be the orthocenter of that triangle. Could I delete point G?
No, it is important.
Okay. Oh, whoops, D I can't move, but I can move the rest. Okay, let me see, how do that looks a little better. Okay. All right.
Then G will lie on AIJ.
On that circle.
Yeah, that you can prove that by power ratio lemma.
Okay.
If we define E and F such that AEDF is a parallelogram.
Okay, so you're defining E and F that way. Okay, and then you want to show they concur at point T. These concur at point T. Okay.
Also, then we know that G, we define G as the intersection of those three circles.
Yeah.
And then we know that BCDG is harmonic, also well known.
Okay. Oh, so then if that's true, then this tangent BC and the tangent at G concur at T, right?
Yeah, and also EF will be parallel to AG. That we can prove that after we prove that AGF is cyclic by power ratio lemma, and that would finish it because then EF would be the perpendicular bisector of DG.
Okay.
And that's
All right.
it.
Okay, so we let these, so basically we define an E prime and an F prime like this. And then we define I and J, and we let G be the intersection of those two circles. And okay, so so I think you said, okay, so G is defined like this, right?
Yeah, as the intersection of those two circles. Then you just need to show that B prime times BA over BJ times BA. That is actually, okay, we don't need like power ratio lemma. You can use spiral similarity. It is a bit easier.
Okay.
Basically, E prime and F prime are corresponding points in similar triangles DBJ and DCI.
Okay. Yeah, that makes sense. And so then that's cyclic. And then how do you know that GB DC is harmonic? Is that obvious?
BC, JI, and AG concur by radical axis theorem. And
Okay.
then you project through A.
Okay. So okay, so what are the three that concur? BC,
AG, and JI.
AG, and JI. Okay. Okay. So then, okay, I think I got it. So I'm gonna start typing it up. Okay, so let the parallels through D. Let me make some room here. I'll just shrink the diagram just a little bit. Put this a little bit out of the way. Parallels through D to AC and AB meet AB and AC at E prime and F prime. And then let BD, let I equal BD intersect AC, and J equal CD intersect AB. Okay. Let ABC intersect AIJ at G. Okay. Then we want to show that AE prime F prime G is cyclic. And that's true basically by spiral similarity because we want to show BE prime over BJ is CF prime over CI, right? And that is true. How do we use the parallel?
Angle JDE prime is 90, and also IDF prime.
Okay. So angle JDE prime equals angle IDF prime equals 90. And so E prime corresponds to F prime. So that means, I think there might even be an easier way to see this. So, but yeah, I mean, so we could say, yeah, by the power ratio lemma, AE prime F prime G is cyclic. So yeah, I'll just write it out that way. So we have BE prime over BJ equals CF prime over CI. That implies AG E prime F prime cyclic by the power ratio lemma. And then IJ, BC, and AG concur. So D is the orthocenter of AJI. First, I'll write that. And so basically BC, JI, and AG concur. I'll prove that in the end if I have time. But BC, JI, and AG concur. And that basically implies that, and then projecting through A, we would find that GB CD is harmonic. I feel like in Vietnam, they really like projective geometry. Although I'm sure there's a way to prove this without projective geometry, but so once we know that's true, that means that TG is tangent to the circle. Okay, so now it's all just projecting because so yeah, how do we finish this? So we know that TG is tangent to the circle.
We want to prove that T prime F prime is parallel to AG. I think that is an angle trace, but can't see it right now.
Okay. And then once we prove that, how would we solve it?
Obviously, E prime O and F prime are collinear, and hence, because AG is perpendicular to DG, then E prime F prime is also perpendicular, and that's it.
Solves it. Okay. So GBDC is harmonic, and so that means TO is perpendicular to DG. So I'll say, first of all, I'll say that means that TG is tangent to AE prime F prime, and that means that TO is perpendicular to DG. Okay, so E prime O and F prime are collinear. And so if we can show that E prime F prime is perpendicular to DG, that would solve it. So could we show angle GAE prime plus AE prime F prime is 180? So or yeah, so we want to show GBC is F prime ED.
Actually, we just project through A. That's how we prove that AG is parallel to E prime F prime.
Oh yeah, that's right. Because B, yeah. So once we know that this is harmonic, projecting through A, then we find that yeah, AG is parallel to E prime F prime. So basically projecting again through A. We have AG is parallel to E prime F prime. And then since TG is tangent, so TO is perpendicular to DG, but EF is perpendicular to DG. So this should imply that E prime F prime is perpendicular. Yeah. So So this implies that E prime, F prime, O, and T are collinear. And that means that E prime equals E, F prime equals F, and that implies OE equals OF. So wow, this is a long, yeah, there had to be a faster one, but I kind of like this solution because it shows how, like, when you have a lot of powerful techniques, you can just eventually crush the problem. So we use the power ratio lemma. We didn't have to. Well, you said we could just use spiral similarity, but yeah, we eventually got through it. So how much more time do we have? We have about 2 more minutes left. I can just go look through that last problem that we were working on. This one looks interesting. Maybe I'll save it for next time. But yeah, we got really close on this one. Let's see. Maybe we'll figure it out in the last second. So yeah, we figured out that HFTE was harmonic. You just project through A to figure that out. And then they all have to concur at G. Yeah, and then we knew that, yeah, because ANOH is cyclic, we then figured out from there that P is the midpoint of TK. And that seems like it's very close to solving it. Interesting. All right. Well, I think I'm going to stop here. Thank you both for staying till the very end. I will have to think of ways to continue to market the channel, but yeah, I appreciate that you guys participate and stay and allow my channel to keep continuing. So thanks a lot. And for everyone watching on YouTube, if you want to join us in the future, feel free to email me at mgreenbeat01@gmail.com. We meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day.